In this video, we'll be taking a look at an interesting concept from game theory known as the Vickery-Clark-Groves mechanism, or VCG. VCG mechanisms are very useful for achieving a socially optimal outcome among a set of people, or agents, because of how it incentivizes each agent to truthfully report how much they value each outcome. Let's use an example to make this more concrete. Let's imagine an auction for a single item, such as this Rubik's Cube, and we have 3 bidders participating. Each bidder is willing to pay a certain amount for the Rubik's Cube. Bidder 1 values the Rubik's Cube at $20, bidder 2 values it at $15, and bidder 3 values it at $10. It may be helpful to organize the different possible outcomes and valuations for outcomes into a table like this. Let's assume that each bidder is only aware of their own value for the Rubik's Cube. So bidder 1 knows he values it at $20, but he doesn't know that bidder 2 values it at $15 or that 3 values it at $10. And similarly for the other bidders. We'll also assume that the auctioneer isn't aware of the bidder's values either, hence why he's running the auction in the first place. The goal with using a VCG mechanism is to pick the outcome which maximizes social welfare. In this auction setting for a single item, this means to award the cube to the bidder who values it the most. Ideally, each bidder would simply tell the auctioneer how much they'd be willing to pay for the Rubik's Cube, and then whoever values it the most would win the cube, in this case bidder 1. However, the bidders can easily lie about their true value for the Rubik's Cube. Bidder 2 could easily say that they value it more than $15, or that they value it at $25, in an attempt to convince the auctioneer to award the cube to them instead of bidder 1. To ensure that the cube is awarded to the bidder who values it the most, the auctioneer has to think about designing the rules for this auction such that everyone would be willing to report their valuations truthfully. That is, to bid exactly how much they're willing to pay for the cube. This is where the VCG mechanism comes into play. In addition to selecting an outcome that maximizes the sum of each agent's values, the VCG mechanism also imposes a payment onto each agent. This payment is composed of 2 functions, which we can represent with the following equation. The notation may seem a bit intimidating, but I promise it's not too complicated, and the idea behind the VCG mechanism is actually quite intuitive. So this first term represents the sum of all the other agents' values for this outcome. So whatever outcome the VCG mechanism decides is optimal, it pays to each agent the sum of everyone else's value for that outcome. The second term represents the total value of the other agents from the alternative outcome that maximizes social welfare, if that agent wasn't present. This probably sounds a bit abstract, so let's try applying it to our auction setting. So in this setting, the socially optimal outcome would be to give the Rubik's Cube to bidder 1. And this should make intuitive sense, because bidder 1 values it the most at $20, and so by giving the cube to him, we maximize the social welfare of this setting. So let's think about what we would pay to bidder 1 in this scenario using our VCG mechanism. Well, remember, this first term represents the sum of values of all the other players from this outcome. But because only bidder 1 receives the item in this socially optimal outcome, the valuation of every other bidder is just going to be 0. So for bidder 1, this first term is going to be 0. Now let's look at the next term. So remember that this is equal to the sum of values from the outcome that we would choose if bidder 1 wasn't in this setting in the first place. So let's imagine what would happen if we removed bidder 1 from this setting. Let's imagine he wasn't even in this auction to begin with. What would be the socially optimal outcome in this case? Well, it would be for us to give the item to bidder 2. When bidder 1 doesn't exist, bidder 2 values the cube the highest at $15, so we should give it to him. The social welfare for this alternative outcome where bidder 1 is non-existent would be $15, since that's how much bidder 2 values the cube, and so this value is going to be equal to $15. So putting this all together, we get that bidder 1 should be charged $15. Let's do a similar calculation for bidder 2. In the original outcome where bidder 1 gets the item, the sum of everyone else's valuation for that outcome is just going to be equal to how much bidder 1 values the item, since, again, he's the only one winning the Rubik's Cube. So in this case, the first term is going to be equal to $20. Now let's imagine what would happen if bidder 2 didn't exist. Well, it would still make sense to auction the item to bidder 1, because whether or not bidder 2 exists in this universe, bidder 1 still values it the most either way. So removing bidder 2 doesn't change what the socially optimal outcome would be. So this next term is also going to be equal to $20. Putting this together, bidder 2's total payment is $0. Now I could go through the same calculation for bidder 3, but it would turn out to also just be $0, since, again, by removing bidder 3, we'd still end up giving the item to bidder 1. Intuitively, the VCG mechanism is a way of paying each agent their net social contribution. This entire equation for what we pay a certain agent is really just saying that we pay each agent the social welfare of others minus the social welfare of others in a scenario where they don't exist. So if this difference is positive, it implies that this agent, by being present in this environment, is making a positive contribution to the welfare of everyone else. Hence why we would make a positive payment to reward them. But if this value is negative, such as in the case with bidder 1, this implies that by this agent existing, they are making everyone else worse off. And that makes sense if you think about it. When bidder 1 is participating in this auction, he's preventing bidder 2 from getting the item. So if we were to remove him, that would allow us to instead award the item to bidder 2. So it can be said that bidder 1 is imposing a social cost into this setting, and that social cost is equal to the value that bidder 2 would have received if he got the cube instead, which is $15, and hence why we would charge bidder 1 $15. With the case of bidder 2 and 3, however, since bidder 1 values the Rubik's Cube the most, it doesn't matter if we take either of them out of this environment. It would still make sense to give the Rubik's Cube to bidder 1, and so bidder 2 doesn't impose any sort of benefit or cost onto anyone else by his participation, and same for bidder 3, which is why we don't make any payment or force them to make any payment. Now, once we determine how much each agent values the outcome we choose, and we determine how much money each agent is paid or forced to pay, we can calculate the net payoffs of each agent. So remember, bidder 1 values the item at $20 and is forced to make a payment of $15, so his net payoff is $5. Bidder 2, because he doesn't receive the cube, values this outcome at $0, and he isn't paid or taxed anything extra, so his net payoff is $0. And we can use the same reasoning for bidder 3. And that's it. We worked out how much each bidder would get in total out of this auction when using the VCG mechanism to decide on the winner, as well as the payment rules. This kind of auction can also be thought of as a second price auction, because the price that the winner is paying is just equal to the second highest bid. In this example, bidder 1 was the highest bidder, valuing the cube at $20, but he only pays bidder 2's bid of $15. So just to sum up, the VCG mechanism is a very useful tool for achieving a socially optimal outcome by incentivizing each participating agent to truthfully reveal their values for any possible outcome. Now, I've been using this example of an auction, but the VCG mechanism can also be applied to many other settings. For example, a government could be deciding on building a public project, and it may want to collect surveys from their citizens to decide on whether or not the benefits are worth the cost of construction. They may also want to impose taxes to fund the project, but they need to make sure citizens don't lie about their value for the project just so that they could avoid paying for it. Another example could involve transportation networking. There could be a network of privately owned railroads, and perhaps we may need to transport goods from one location to another, and we'd like to minimize the total cost of transportation. We could ask the owners of each railroad to report to us their individual costs for utilizing their routes. But if we're assuming that each owner is self-interested, they may have an incentive to lie about how much it costs them to ship goods across their railroad. One of these owners could tell us that their cost is a lot higher than it really is, just so that they could avoid the financial burden of us shipping along their route. I'll dive a bit deeper into this whole idea of truthful reporting in the future, and we'll hopefully look at a few other interesting scenarios with VCG. But for now, I hope that this served as a good introduction. I really hope you enjoyed watching, and I look forward to seeing you again.